So we are starting from the question number 96. Here the question is the figure below shows the position of the pointers at rest with the identical springs loaded with different masses. And also they have considered the value of G as 10 meter per second. So if we compare these two conditions, and you can see the mass has been reduced by 10 kg, and for this extension has reduced by 20 centimeters. So from the formula we can write F is equals to mg is equals to kx. So mass reduced by 10 kg, that is 10, and g is here 10, k we have to find it out, and x the reduction is 20 centimeter, that is 20 by 100. So it will be k will be 500 newton per meter. Now we will we use this concept of the value of k in the next condition, in which we are comparing the first case and the third case. Now you can see the reduction of mass here is 20 minus x into g equals to kx. Kx means here x we are considering the displacement. So the reduction in the displacement is 30 centimeter, that is 30 by 100. So we have to find out x from here. So 20 minus x, g means 10, equals to k we have got 500 into 30 by 100. So from here two zeros will be cancelled out, and 10 and 10 will be cancelled out. So finally here will be 20 minus x equals to 15, or x equals to 5 kg. So our correct option will be one number, x equals to 5 kg. Moving to the second question. So it is written, a person applies a force to move a 20 gram object in a vertical plane from a position A to position B along a circular track of radius 50 meter. What is the amount of work done by the person? As we are taking against the gravity, that means we are working against the gravitational force, and as the gravitational force is conservative in nature, so the work done will not depend on the path. It will just the distance or displacement between initial and final point. And the radius already given here, it is 50 meter. So the diameter will be 2 into 50, that is 100 meter. So diameter we have got mass m is equals to 20 gram, means 20 by 1000 kg, or you can write 0.02 kgs. And work done, you know, the work done w equals to, here we have to consider it as mgh. M is 0.02, g we have to consider 10, and the displacement here is 100. So ultimately we are getting 20 newton meter. Work done will be 20 newton. The second option is the correct one. These questions are very basic in nature. One of the most easiest questions that we are getting in KBS. Now our next question is, a particle is moving in xy plane under the variable force. So the amount of force they has given to us is F is equals to minus 7 3y I cap plus 7 j cap, and all they have given I cap and j cap are unit vectors along x and y axis respectively. The particle is taken from the origin along positive x-axis 2.5, 0 meter, and along y-axis another 5 meter along y-axis. So graphically it will be situated at this point. It is 5, it is 5. So it is the origin O. If this consider also this point as A, so OA will become 5 I cap plus 5 j cap. 5 I cap and 5 j cap we will get. So we have to find out what's total work done again. So work done is what? F dot ds. We know ds means displacement. Here I am writing F vector dot OA vector. So vectorically minus 7 3 y here is at this point y is 5 meter, so I am directly writing y into 5, 3 into 5 I cap minus plus 7 j cap, and dot product as we are doing 5 I cap plus 5 j cap. So if we do this dot product I cap and there is I cap, so and I'm multiplying this minus 7 inside this bracket, so the first term will look like this: 7 into 3 into 5 into 5, and the second equation will look like this: minus 7 into 7, 7 into 7 into 5. Now if I am multiplying the whole thing, so here will be uh, 21 into 25 minus 21 into 25 minus here is 49 into 45. So 21 25 is 52, and here it is 24. So finally it is minus 770 Newton meter. The fourth option is the correct one. Going to the next question. The question is: a motor delivers a minimum power of 28 kilowatt to lift moving upwards with uniform speed of 22 meter per second, and frictional force opposing in nature is 2000 Newton. It is opposing in nature, that means it will not help us, rather it will start to dissipate the total force. So and the lift of the cabin is 800 kg. So writing it distinguishedly, mass of the cabin is 800 kg, and they asked us to find out the total load that this lift can carry upwards. So here we have to find out the total amount of force the lift can carry. So we know power is equals to force into velocity. So power they have given 28 kilowatt, and force we have to find it out. Velocity is 2 meter per second. So in this case 28 kilowatt means 28,000 by 2, it will become 14,000 Newton, and frictional force is opposing the motion is 2000 Newton. So here frictional force which is not helping us, which will destroying our total force, and the amount of friction 2000 Newton. So F effective or F net will become F minus Fr. F is 14,000 minus 2000, it will become 12,000 Newton we will get, that is effective or net force in the upward direction. So we also know force equals to mass into gravitational acceleration. So here we are getting 12,000 Newton mass. We have to find it out. Total mass, the lift with the load it will carry, G is 10. So total mass we will get 1200 kg, and the lift itself is 800 kg. Cabin is itself 800 kg. So the load it can carry, it will be m minus mass of the cabin, that is 1200 minus 800, that is 400 kg it will carry in upward direction. So the third option is the correct one. Moving to the next question. Here there is a ball they have given of mass 200 gram, and it is at rest at an external force F varying with time as shown in figure is applied on the ball. The speed of the ball at 2 seconds, 0.2, 0.4 and 0.6 second, and V1, V2 and V3. So then we have to find out the ratio of the speeds. Now if you look at the graph, there it is actually force versus time graph. So the area of this kind of graph f versus t graph gives us impulse. So we can solve it by considering the impulse part. So impulse is also change in momentum. So doing the first thing, the first part, there is a first triangle. Now the area of the triangle is half into base into height. The base is here 0.2 as I can see, and height is 0.2, which will give us change in momentum, that is mass into v1 minus initial velocity. v1 is the velocity that is after 0.2 seconds. Initial velocity is 0 as it is given the object was at rest at the beginning. So here we will get um, mass is 200 gram. So by putting all those things, 2 here is 0.2, that is 0.1 into 0.2 into mass is 200 gram, that is 200 by 1000. I am doing a step jump over here. It will be like this into v1 as u is 0, initial velocity is 0. So solving all these, two zeros cancelled out each other, and here is 2, we cancel it, it will be 0.1. So v1 will ultimately, it will look like this, 0.1 meter per second. Similarly, we have to find out the v2, that is after the 0.4 seconds. Again, we have to consider the whole area of this triangle and this square part, not square, it is rectangle part. So the area of the triangle, as we are getting from here, 0. Half into 0.2 into 0.2. So for the second case, 0.2 into 0.2 plus area of this rectangle or quadrilateral, it will be side into side, 0.1 into 0.2 equals to change in momentum, m into v2 minus u. Again, it will look like this. Simplifying it, I will get 0.1 into 0.2 plus 0.1 into 0.2 divided by m equals to v2. So it will be 2 into 0.1 into 0.2 divided by 200 gram means 200 by 1000. So 1000 will go in the numerator and we will get v2. So two zeros we are cancelling out. So finally 2 will cancel out, and here we are getting v2 as 0.2. And finally we have to find out the v3. Again we have to consider the third portion, and you can see the third portion, the force is in the negative direction, so it will we are having negative force here. So total area of this first triangle, then rectangle, and also this triangle, it will give the negative area. So total we will get like this plus this whole thing, half into 0.2 into 0.2 plus 0.1 into 0.2, and the area of this portion minus half into 0, 0.2 into 0.2 equals to, again, change in momentum, v3 minus u. So here you can see these two parts are cancelling out each other, and v3 will be 0.1 into 0.2 by m means 200 by 1000, and 1000 go in the numerator. Two zeros will be cancelled out. So finally we will get from here 0.1 meter per second after simplifying it. Now if we take the ratio of this thing, take the ratio of v2 by v1, you can see it is v2 we are getting 0.2, and v1 we are getting 0.1. So finally it will be 2, and v3 by v2 it will be 0.1 by 0.2, it is 1 by 2, that is 0.5. So we can see the option 2 is the correct one. So today is up to this one, up to this much. The next day we'll go to the next 5 questions.